Alright, intermediate 10, functions. This is going to deal with function notation, what a function is, and trig functions, which is a good topic, the old trig functions. So here's an example of a relationship. Any relationship can be thought of as a function. We got days of the week as the first column and the meals as the second. So you can think of this as inputs and outputs. You input a Monday, and what do you get? Turkey meatloaf. Input a Tuesday, you get grilled cheese and pickles. It sounds disgusting. Input a Friday, you get barbecue chicken. So we could call this the domain, what you put in, and the function, we could call this column what you get out. It's just an example. Here's another example. It's not an actual problem, I'm just going to talk about it. Group of 5 friends purchased tickets for a Chicago White Sox game at the U.S. Cellular Field. Ronan's seat is in section 124, row 5, seat 1. Omar's seat is in section 124, row 5, seat 2. James is in the same section, row 5, seat 3. Jack is in the same section, row 5, seat 4, and Andrew is in same section, same row, seat 5. The relationship between the attendees and the range represents 5 ordered pairs. So the people, we could say, like for example, Ronan, he's in seat 1. Omar is in seat 2. James is in seat 3. And then Jack, of course it starts with the same letter as James, is in seat 4. And Andrew is in seat 5. Those are ordered pairs. Lots of times when you're given information, this is not one of those times honestly, you would write the information in ordered pairs, and it's going to help you work out the problem better. On a singing reality show, one of the 7 singers in the contest is assigned a text message number. Yada yada yada. So what this means is for each singer would be the domain and the range would be the phone number. Every singer has a name, everyone has a phone number, and the ordered pairs. Alright, so let's do a real example. Mathematical relationships. It's not a real example, just more explaining, I guess. So this shows the relationship between x and y. Any number that you put, any number that you put in for x, to get the y value, you have to square x, multiply it by itself, and then subtract 6, for example. So you put a 1 in. That's going to be 1 squared minus 6, which is going to be negative 5. Put a 2 in, it's going to be 2 squared, which is 4, minus 6, which is negative 2. So you put in a negative 3. It's going to be 9 minus 6, it's going to be 3. This describes the relationship between those two things, x and y. If we were to graph this, if you've had Algebra 2, you should know how to graph this, or maybe you haven't got to it yet. Depends on when you're taking this class. But the y-intercept is a negative 6. It's a parabola that opens up. So the graph looks something like this. Not a real problem, just showing you this different relationships. Here, f of x equals x cubed minus 4. That graph is going to look something like this. It's like 2 parts of a parabola. One part opens up, one part opens down. So whatever we put in for x, the y value has to be x cubed minus 4. Put a 0 in, 0 cubed minus 4 is negative 4. Put a 1 in, 1 cubed minus 4 is 1 minus 4, which is negative 3. Put a 2 in, 2 cubed is 8, 8 minus 4 is 4. A function shows the relationship between two different things. And here's that graph to scale. y equals x cubed minus 4. Vertex being right around there. All right, let's do some evaluations of different functions. If f of x is negative x squared plus 5, what is f of negative 2? This just means that we take this negative 2 and we plug it in for all the x values into this problem. So we have f of negative 2 equals negative 2 squared plus 5. It's important when you substitute into a function that you use parentheses. You've got to follow order of operations, which is to square this first. Negative 2 squared is 4. Then apply the negative that's on the outside. So that's a negative 4 minus 5, which is negative 9. Common mistake that people make for this problem is they say negative negative is positive. Well, that's not true. It's true in certain contexts, not in this context. Order of operations, you do parentheses first, which is a negative 2, nothing to do there. Then you do exponents, which is going to be the squared. Number 2, similar problem. We are supposed to substitute a negative 2 into this problem. When you substitute, use parentheses. You will make a lot less mistakes if you use parentheses. A negative 2 squared is 4, plus a minus 2 is a minus 2. Minus 4 minus 2 is a minus 6. Minus 6 plus 3 is a minus 3. All right, number 3. We got two different functions, and it wants to know the value of f of g of negative 1. Let's just do one thing at a time. Let's figure out what g of negative 1 is first. That's negative 1 squared minus 3, which is 1 minus 3, which is negative 2. So if g of negative 1 is negative 2, now we're going to plug in this negative 2 in for f. It's negative 4 minus 7, which is negative 11. Dunsies. Example 4. What is f of 4? So we got f of 4 equals, use parentheses when you substitute, four squared is 16 minus 4. If you recall from an earlier lesson, anything to the 0 power, with the exception of 0, is 0. Pardon me, is 1. Not 0, it's 1. 2 times 16 is 32. Minus 4 and a minus 1 is a minus 5. That makes this 27. Number 5, just another example. We're supposed to put a negative 2 in for x. When you substitute, use, that's right, parentheses. So a negative 2 cubed means a negative 2 times itself again. 2 times 2 times 2 is 8. You're multiplying three negative numbers, negative 2 and negative 2 and negative 2, so it's a negative 8. A negative 2 squared is positive 4. Subtracting a negative 2 is the same as plus 4. 3 times negative 8 is negative 24. 4 plus 4 is 8. That makes this negative 16. So I made a mistake someplace because that's not one of the answers. Let's see if we can find this. Oh, I see what it is. I changed a minus negative 2 to a 4, which is ridiculous. Should just be a 2. 4 plus 2 is 6. Negative 24 plus 6 is negative 18. which is one of the answers. Exciting times. Number 6, putting in a half. Oh, bother. When you substitute, use parentheses. When you square a fraction, you square the top and you square the bottom both. So that means this is going to be a negative 1 to the 5th is 1. 2 to the 5th is 32 minus 1 cubed is 1, 2 cubed is 8, plus a half. Need common denominators to add these together. 8 times 4 is 32. 2 times 16 is 32. So we get negative 1 minus 4 plus 16. When you're adding or subtracting fractions, you add or subtract the top numbers. So it's negative 5 plus 16. That's 11. Bottom number stays the same. We got 11/32. Done. Page 3. Trigonometry. There's many things to tell you about this. If you find that when I'm finished I did not go into it deep enough, let me know and I will try to figure out a way to get deeper. When you're dealing with trigonometry, and in most cases, for the ACT, probably all cases, you're dealing with a right triangle. So if it's a right triangle, you can use trig. If it's not a right triangle, let's say that you can't. A right triangle has a right angle, and the trig functions that we're going to use all deal with an acute angle. So this is an acute angle, A. Relative to angle A, always talking about relativity to one of the acute angles. This side here is the adjacent leg because it touches it. Right leg there. This is the opposite leg because it does not touch it. And then this is always the hypotenuse, that's opposite 90. Adjacent and opposite are legs, and the hypotenuse is not a leg. Sine of angle A is equal to the opposite leg divided by the hypotenuse. That is a fact about trig functions. Cosine of angle A is the adjacent leg over the hypotenuse, and tangent of angle A is the opposite leg over the adjacent leg. Now if we were to start, let me draw a different picture and yet the same picture. If we were to start with this angle up here, angle B, then the adjacent leg would be this one and the opposite leg would be this one. Hypotenuse doesn't change. So remember, it's always relative to your acute angle. Well, let me remind you of one other thing, which is this ancient Indian word. It's an acronym. SOH is sine is opposite leg over hypotenuse. CAH is cosine is the adjacent leg over hypotenuse. TOA is tangent is the opposite leg over the adjacent leg. How you pronounce this is as follows. So, ka, to, a. So, ka, to, a. Let's do an example. In the figure below, what is the length of side A? Well, using trigonometry, we're going to identify the acute angle we're using, which is 40 degrees, then identify the two sides that you have, either the lengths of that you're trying to find the length of. We know the length of 12, and we don't know the length of A. It's going to be tangent because 12 is the adjacent leg and A is the opposite leg. So we go tangent of our acute angle equals the opposite leg, which is an A, over the adjacent leg, which is 12. Now we use algebra To get a by itself, I'm going to multiply both sides of the equation by 12. We get 12 times tangent of 40 degrees equals a. Type that in your calculator, making sure your calculator is in degree mode. Let me do that real quick. It's going to be 12 tangent of 40. That's about 10.069. Now your answer that you get, you should know if it's a ridiculous answer. This is not ridiculous. It's close to the 12. If you get an answer like 50 or something, something would be up. All right, let's check out this next one. Start out with your acute angle, 25. 8 is the opposite leg. B is the hypotenuse. What trig function uses the opposite leg and hypotenuse? Well, it's sine, of course. Sine of the acute angle, 25 degrees, is 8 over b. Trying to get b by itself, we're going to have to multiply both sides of the equation by b to get it off the fraction. So now we have b times sine of 25 degrees equals 8. Trying to get b by itself, we're going to divide both sides by sine of 25 degrees. Put that in my calculator. That's about 18.93 ish. And that makes the hypotenuse larger than a leg. So that's good because that's what should happen. Number 3 in the figure below, what is the length of C? Well, we have an acute angle, we have the adjacent leg and hypotenuse, that's going to be cosine. Cosine of 60 degrees is the adjacent leg over the hypotenuse. Multiply both sides by 15. 15 cosine of 60 is 7.5. Done. Now this problem could have also been done in another way. This is a special right triangle. Special right triangles are one of the most important things you could ever learn in math because they are used all over the place. In a 30, 60, 90 triangle, opposite 30, let's call beta, opposite 60 is always twice that. Pardon me, opposite 90 is always twice whatever is opposite 30. The larger leg, opposite 60, is always whatever opposite the shorter leg times the square root of 3. So looking at this, if 15 is 2 beta, that means that beta has to be half of that. C has to be half of that, which is 7.5. So finished. All the intermediate lessons are done. Please do exercise set 10. Go ahead and put a smile on your face. And if you have a Twix bar, you have my permission to eat it, as long as you have enough for everyone.